Yeah, so hi all, very good evening. Can you hear me? Is my screen visible?
Yes, sir.
Okay, great. So today we'll be uh, covering the questions related to week 4 content mostly. And since many of you had requested or presented that you have doubts in the TFID questions from week 2, we'll just have a brief overview of them towards the end of the session. Okay, so uh, without further ado, let's get started. So yeah, welcome once again to the fourth week of the TA live session for artificial intelligence search methods for problem solving, and let's get started. Yeah. So here is the first question. It's quite a straightforward question directly from a concept talked about in the lecture. So which of these do you think would be the correct option or options? So this is an influence graph uh, shown on the left hand side, and it depicts a closed ecosystem. And using just the information that is given to you using this graph, which of the options mentioned on the right hand side do you think would be true? Anyone? B. Okay, so we have one answer. Someone says it's B. Okay, okay, that might be correct. Anyone else? Uh, is B the only correct option, or can there be more options as well?
More options.
Okay, so we have another. Oh, we have quite a few uh, options in the chat. So we have B, N, F, and E. So let's have a look at the answer. So the answer would be these three options are the right options in this case. And why? Let's see. So the second option is grass has indirect positive influence on lions. So if we just follow the influence graph shown over here, we have grass over here. Let me just share my Jamboard. Yeah. So we have grass over here, and we can see that grass has a positive influence on mouse, mouse on snake, this on hawk, hawk on fungi, and so on and so forth. If we follow this, one way we'll reach the lion. Let's say using this way. So we can say that grass has a positive influence on lions. Similarly, if we have a look at the other options, bacteria has an indirect influence, positive influence on fungi. So bacteria as an indirect influence, we just follow this path. This is true. And then hawk has a direct positive influence on fungi. So this is a pretty self-explanatory question. So I hope there are no doubts from this. Uh, is that fine? Are there any doubts from this question?
No, sir. No doubts.
Okay, great. So let's quickly move on.
Sir,
Yes.
can you please explain what the question was because I just joined right now?
Yeah. So let's do one thing. Let's move on to with the next few questions, and in the end, if we have time, we can revisit. Otherwise, you can always go back to the recordings because the previous question was not really, not didn't require much of explanation. So I hope you'll be able to get it on your own.
Okay, sir.
Yeah. So this is the second question. Yeah. So you have 5-bit binary strings, okay, and a fitness function. Consider taking in those variables a, b, c, d, e, and that function is defined as the square of this term, which is a plus 2b plus 3c plus 4d plus 5e. Okay, so this is our function, and we are asked to fill this table. Okay, so let's try to solve it step by step. So first of all, for this particular configuration of a, b, c, d, and e, what do you think will be the function value over here?
5.
Okay, remember that the function is a square of the term a plus 2b plus.
25.
Yeah, that's correct. So this will be 25. And similarly, what are these values? Can some of you just tell me quickly?
49.
Okay, 49.
100.
64, right?
5.
And this will be, I think, 196. So you can verify for yourself. So is this clear until this point? Okay, yeah, so we have an answer in the chat itself. That's great. Yeah,
Uh, Kamal, can you please explain how did we arrive at this?
sure. So I'll just take one of these samples. Let's say the first one. So we have 1 0 0 1 0. These are nothing but the values that these variables are taking. Okay, and if we go back to the term that we had, what was that? A plus 2b plus 3c plus 4d plus 5e and square. So if we just put in these values of a, which is 1, and d, which is 1, and all of this are 0, we are getting basically 5 square, which is 25. So was that helpful?
Yes, thanks.
Okay, great. So if that is clear, we can just straight away calculate the sum. I suppose it will be something like 334. Can you verify this for me, please?
Yes, it's 30.
Okay, great. Yeah. So once we have the individual function values and the sum, we can calculate the probabilities, right? So the probability for the first one, this will be what?
25 by 334.
Yeah, that's correct. And what's that evaluating to?
0.07.
Okay,
This is
so
0.075.
okay, so let's say it's 0.07. Similarly, if we calculate the probabilities for the other ones, we'll get a certain set of values.
0.146.
Okay, 0.146. Let's round it off to 0.15. Then,
0.19.
okay, 0.19. And this,
0.5.
I suppose, is
0.58.
0.59. I guess we can round it off to 0.59 using the.
Yeah, it's 0.59.
Okay, so we have got the function values, we have got the probabilities. It is clear up till this point?
Yes.
Okay, great. So for getting the expected value, what we do is here we have 4 candidates, right? In our initial population, there are 4. 1, 2, 3, 4. So what we do is exactly we multiply it by 4 and to get the expected value. So what we get here is
0.28, 0.6, 0.76.
yeah, 0.28, 0.6, 0.7.
0.76.
Okay, and this one is
Last one is 2.36.
okay. Great. So we have got the expected values as well. Now, how will we get this actual one? So we just take a look at this expected value. Okay, and we see that this expected value for the first one, it's quite low, 0.28. Okay, so we'll not take this first one into the next generation population. So this will be 0. Okay, and this is quite high, the last one. So we'll take 2 of these. Okay, and these are considerably relatively hu- bigger, but not as low as the first one. So we'll take one each of these. So
If they were considerably bigger, then we will take 2 instances of one of them.
yeah, see, so it basically
Like
depends.
one of them was 0.5 and other one was 1, then we would have taken the one instance 2 times.
Yeah, that is recommended. So see, we have to make an arrangement among the values in the actual column so that the total remains to 4. Okay, and I would recommend you to encourage you to have a look at one of the explanations by Bhaskaran sir on the discussion forum regarding this exact issue of getting the actual values from the expected values if you have any doubt about it. Okay, yeah. So we have got the actual values. So is it clear until this point? We have
Yes.
we have filled in the table.
Yes.
Okay,
So
great.
now, if we are printing the answers, do you see going sequence wise or the fittest factor first?
Vineet, your voice is breaking. Can you maybe bring the microphone closer to you?
Am I audible now?
Yeah.
Yeah, I was asking like when we are printing them in order, so better will consider the sequential or the fittest first?
I'm sorry, Vineet, your voice is still breaking. Can you maybe type it in the chat, your question?
Just give me a moment.
Yeah, sure. Fatima, I can repeat once, but I okay. So I'll do one thing. Mayuk again. So how we got 25, I've just explained a few moments ago. So if you missed it, if you just joined, don't worry. You can just have a look, like go back to the recording and have a look at it. If we have time towards the end, I'll revisit this question and explain it once more.
So I will just. Am I audible now?
Yeah, Vineet, you're audible.
Yeah. So my question was like we have four basically binary strings here,
Yeah,
5 bit. So
yeah.
I was asking like when we are taking this for the next generation,
Mm-hmm.
so we will be taking it BCD or the fittest factor first. So DCB while we are printing it.
Okay, so that actually doesn't matter. So if you're just forming the population, you can print it in any order. But when you are selecting for crossover, say, then you have to select on a certain basis. Then you can choose to maybe select the fittest one first and choose it to act as a parent in the crossover part of the algorithm.
Okay.
Yeah,
Just
Excuse me,
for
sir.
yeah. Tell me.
Sir, can after this, can you explain this question once again? I didn't think I properly understood the thing here.
Okay.
may I,
Let's.
sir?
Yeah, Vinny, tell me.
Yeah. Okay. Actually, what we have done, Mr. Mayuk, what we have done is that we have a table here. We have been given five binary strings, which you can see ones and zeros. So what we are doing, we are given a function, which you can see on the screen: a plus 2b plus 3c plus 4d plus 5e.
Squared.
So then the square. So what we are taking, whatever the values are given in 5-bit binary string, we are basically putting them in place of A, B, C, D, E. So suppose we take the example of first. So we put A equal to 1, B equal to 0, C equal to 0, D equal to 1 and E equal to 0. So that will give you 5 and then squared 25. Similar way we have calculated the others. After that we take out the sum. We divide it by 4 because we have got 4 5 binary strings. We get 83.5. Then we take probability. Probability is the total upon the sum. So like 25 upon 334, 49 upon 334. And the expected value is probability multiplied by 4 because we have got 4 binary strings. So if we take a rotational, you can say disk, so there are, it will be divided in 4 sectors. That particular sector probability will be 1 by 4, but it will divide in 4 sectors. That is why we have taken expected value divided multiplied by 4. Am I like helpful?
Yeah, Vineet. You gave a great explanation. So was that helpful? Yusuf? I think Yusuf had asked it, right?
Uh, yes, sir. So actually, I actually didn't follow that part. As in, why are we taking this probability like that? So can you explain that? I think. Yeah.
Yeah, so basically this in this question what we are trying to do is we have an initial population. Okay, this is a sample explanation of the genetic algorithm. Okay, so we have started with an initial population which is represented by these four strings that you see on your left hand side of the table. Okay, and we are using this function that we have given over here, a plus 2b plus 3c plus 4d plus 5e squared, as the fitness value. Okay, and then proportional to the fitness value, so we are taking which of these candidate solutions, these candidates, these strings could be passed on to the next generation. Okay, and we are calculate for doing that, we are calculating the probability and then the expectation, because there are four particular strings over here. So let me, if I just give a quick explanation, let's say if this was a wheel, okay, and you had different sectors corresponding to the different probabilities of the various the four strings over here. You, let's say you run this wheel four times, okay, because we want four solutions in the next generation as well. Okay, so this is the initial generation, this is the next generation. We want four candidates over here, and each time we, so each time we rotate this wheel, we have to multiply this probability by 4 to get the expected value. So was this helpful in clearing the intuition?
Yes, sir.
Yes, sir.
Sir,
Okay.
this F function for our, it will be different for other problems, no, sir? Like
Yeah,
F
yeah,
physics.
definitely.
But
Yeah,
this
yeah,
particular problem, it is F plus 2, A plus 2A, 2B plus 3C and all.
yeah, yeah, definitely. Depending on the problem at hand, the fitness function or the cost function will change. Okay, thank you so much for the great discussion we
Kamal,
just had.
sir, one moment. I have one question. I
Yeah.
understood everything, but I'm not able to understand how we take the range from 0 to 4. I missed that, but I'm sorry about it.
Which range? The range of actual, is it?
In the answer, you mentioned that the ranges is from 0 to 4, but I did not understand how we arrive at 0 to 4.
Ah, okay.
Because
Initial.
we have 0, 1, 1, 2, right?
This one,
So,
right?
yeah.
Yeah. So basically, this basically represents how many of these particular strings do we want in the next generation. So this zero represents we want zero instances of this particular string in
Hmm.
this next generation. We want one instance of this string in the next generation, one instance of this string in the next generation, and two of this string in the next generation. Now, since we want only four strings in the next generation, the sum of all these values should come up to 4. That's what I was trying to say.
Okay.
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 So, suppose we had a situation where this expected value was almost 0 for 3 of these and a
Hmm.
huge for one of these. We'll just take 4 of those. Although that would be a very skewed population, but anyway, just for the sake of explanation.
Okay.
So the actual value is like the round off of the expected value?
Not an exact round off, but in a way, yes. So again, I would like to encourage you to have a look at the explanation by Bhaskaran sir on this exact topic. Just go to the discussion forum and search expected value to actual value, and you will find that someone already has asked this doubt.
Okay, sir.
Okay, so there were a number of queries related to the recordings and the previous questions, so I'll just address them quickly. So if you have missed any of the previous questions, we just discussed one question before this, so don't worry, you can revisit the recordings and have a look at it. The recording will be available on the Swayam portal. You'll see there's an option called problem solving session. If you go to that link, then all the recordings will be available over there. The links to all the recordings will be available over there. Okay,
Yes. Sir,
so
sir,
yeah, tell me.
sir, actually, the maximum probability string should be taken 2 times and other string should be taken 1 time. Is it a rule like that?
It is mostly the case, but it may not always be true. Again, I would say that just have a look at that explanation by Bhaskaran sir. That'll I guess help you clarify your issue, that doubt that you are having.
Okay, sir. Okay, sir. Thank you, sir.
Sir,
Yeah.
if that condition that if average that if, like here in example the fourth got 2 probability is 2, but in the next cycle if that failed, then it will again come back, like mutation process will happen here, no sir? That it will again come back and take some other value
Right.
and continue the process.
Right. The next, that will depend on, that will again change because the probability will change in the next generation. So the population will change, and hence the sum total will change, and hence the probability will change. So depending on all those factors, the whether or not it carries forward to the further generations will change again. Okay, so I hope there's no further doubt in this question. Let's just move on to the next question. I guess we already discussed it and discussed this actually. So the individual instances selected for the crossover are basically the instances that move on, that we get in the next generation. Anyone?
D and B, C.
Yeah. So what would the next generation look like? Like, can you just tell the strings that would be present in the next generation?
Zero
0
one zero
and
zero
1.
one
Okay.
00101
Okay.
01111 01111.
Yeah, that's perfect. So quite straightforward. That we just discussed this. Just this one represents, there will be one instance of these 01001 and 00101 in the next generation, and two instances of this last string. So these are the instances selected for crossover.
Sir, but for example, if we say the last one has probability 3 and the B or C has either 0 or 1, then it will take 3 and 1 like that.
That might be the case. So once again, I would say just have a look at that Bhaskaran sir's explanation, and that will probably help. Okay, yeah. Okay, so let's quickly move on to the fourth question. Okay, so what do you think about this question? So here we have four graphs. Okay, and for each graph, we have to produce a tour by traversing only along the given edges. So basically, the conditions are you have to start at any one of the nodes. Okay, any one of the points. You have to travel through all the points and come back to the same node. Okay, so which of these graphs in these four graphs can you actually do that? What do you think?
A, A.
Okay, okay, in A we can do that. Okay, what about the other graphs? Okay, and remember, another condition is that you cannot visit any node twice. Okay, so we have one answer in the chat. So someone says that it's A
C.
and C.
A and C.
Okay, so let's have a look whether that would be possible or not. So let's say A. So let's say we start at this node. So we travel in this direction, and we have covered all nodes, and we can easily get back to the node where we started. So A is correct. Let's look at C then. In C also we can similarly do the same thing using some traversal. Okay, let's say something like this, right? But in B or D, we cannot do that. I'll just give a illustration. See, so in A and C, we were able to travel through all the nodes and come back, return to the node where we started. Whereas in B, let's see, we are stuck at this middle node. If you start at the bottom leftmost node, we are stuck at this middle node, and there is no way to go back to the node where we started without traveling or without visiting one of the nodes twice. So B is not correct. Similarly, D is also not correct. So is this clear or any doubt about this?
Yeah, we are good.
Okay, great. Yeah, great. Okay, so the previous question was an intuition for TSP. So let's have a look at some of the path representation that could be. Okay, so this is basically a graph or a tour, you could say, and which of these are valid path representations of this particular tour? What would you, which of these do you think are valid path representations? Okay.
Sir, A.
Okay, we have an answer A.
C.
Okay, we have another answer C. So,
A, C.
okay. Does everyone agree with it? Okay. Seems like everyone agrees with it.
AC.
Okay. Yeah, Shruti, if you have a question, you can unmute yourself and ask. Okay.
Whenever we are representing a graph like this,
Uh-huh.
so it will be all the nodes included except matlab we don't make a repetition. So like if it is starting from y, it will finish at p without y included again at the end.
Yeah, I mean, your intention is that if you just revisit the problem of TSP, that you start from one of the cities, you visit all other cities exactly once and return to the starting point. Okay,
Yeah.
so in the tour, we don't mention the starting point again at the end, but it is implied.
So, but for representation purpose, we exclude the point again once.
Yeah,
It will
exactly.
only, it will basically all the points will be mentioned once only in the list.
Exactly.
Okay, okay, thank you.
Yeah. So let's just have a look. So suppose we start from, what was the first option? We started from R and we went to U. So we started from R, we went to U, then S, T, Y, Q, Z, V, P, W, and X. And then we are revisiting R, which we are not mentioning over here. So that was the first option. So A is correct, which we all agree with. Now B is not correct because B just enlists at P, Q, R, S, T, U, V. And here only, the first point only, we can see that if we start from P, we cannot directly go to Q without going through V and Z or other way around. So B is not a correct option. Similarly, C, if we go to C, we start from P and then follow V, Z, and Q and so on and so forth. We start from here and something like this. So this is also correct, and D again is not correct. So this was pretty straightforward. So yeah, I hope that's clear to all of you. Now we saw a path representation. Now, which of the following do you think is a valid or are valid adjacency representations of the tour? So do you remember what an adjacency representation is?
Can you explain once, please?
Sir, is it like adjacency list?
Okay, so let's do one thing. So since there are a few doubts, let's discuss it. So adjacency representation is basically it's for those who are familiar with an array notation in computer science. It will be intuitive for them to understand. Corresponding to every index, there is a particular node. Okay, for those who don't know about this, there's no reason to worry. So suppose this is a reference sequence, okay, shown in this green font over here, okay, which is the alphabetically listed order P, Q, R, S, T, U up to Z. Okay, and this is one of the options that we had. Okay, so see W, Z, U, T. This was one of the options. So let's say which option it was. This was the second option, I think, B. So just see this between each individual pair. Okay, W and P. They are connected, right? They are adjacent to each other. So this is fine. Look at Z and Q. They are adjacent to each other. So this is fine. Look at U and R. Again, these are adjacent. This is fine. T and S, again adjacent. Y and T, again adjacent, so this is fine. So on, you can just proceed and verify for each of these pairs that for each of these alphabets in the reference sequence, we have an adjacent node in the option that is given to us, this one. So we can say if all of these are correct, that this is a valid adjacency representation. So was the first example clear?
Yes.
Yes, sir.
Okay, so let's quickly have
Sir,
a look.
how P1 and P2 we got P1 and P2.
You just have the options, right? In the question itself, you had the options, right? This particular ones.
Okay, so we are comparing with that option, sir.
Yeah. We just so in this question, we are just required to find which of these are valid adjacency representations, right? For that, we have to compare with the reference sequence, and for that, we are taking each of the examples and then comparing it with the reference sequence. Okay. So similarly, the this example, this is the last, the dth option, I mean fourth option. This is also, if you have a look at it, you'll see that this is a valid adjacency representation. Let's just
Yes, sir.
quickly have a look at one of the wrong answers so that it's clear to you. Let's take a look at, let's say, R. Okay, so the first one starts with RUST. So RUST, this is the first option, let's say, so on and so forth, or Ath option. So is P adjacent to R? No, right? P is adjacent to only W and V. So first only we can deduce that this is a wrong, not a valid adjacency representation. Jugal, yes. So in this case, the example that we have taken, we have listed the reference sequence in alphabetical order. So that is the case, yes.
So, but the reference sequence need not be alphabetical always, right? I mean, it's a or
See,
like can it be some?
since you are defining the nodes in an alphabetical way, it's that in terms of alphabets, let's say it makes sense to have the reference sequence in an alphabetical order. If say you had defined the nodes numerically, then you would have a certain different reference sequence. Let's say that would be a numerical order. Let's say 1, 2, 3, 4, 5, 6, something like that, right?
Okay, sir.
Yeah, just think about it. Take a few examples and try to see what could happen if we took a different representation. Okay, so I hope that was clear. So B and D are the correct options, right? Uh, any doubt about this?
No, sir.
Okay,
No, sir.
great. So let's move on to the seventh question. So see, this one was one of the valid path representations we saw in the fifth question. This RUSTYQZVPWX. So what would be the corresponding ordinal representation? Do you remember what is the ordinal representation?
1, 2, 2.
Yes.
Numerical index you have to assign.
Yeah, something like that. So again, we'll use the reference sequence. Okay, and we will assign values to this 1, 2, 3, so on and so forth. Okay, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11. Okay, and we'll consider each of these nodes one by one from the path. Okay, so first we had R, and what is the index of R over here? Is 3. Okay, so the ordinal representation will have 3 first. Okay, and then what we will do is we will remove R from here. Okay, so we will have P, Q, S, T, U, V, W, X, Y, and Z, and the index will change accordingly. So this will become 3 now instead of 4. Okay, is it clear until this point?
Yes, sir.
Yes.
Yes, sir.
Okay, so similarly, now that we have considered R, let's take a look at U. So what is the index of U over here? It's 5. And then we'll remove U. So we have P, Q, S, T, V, W, X, Y, Z. So does anyone remember what is actually the benefit of using ordinal representations? Like, why do we need an ordinal representations? We could always do with path representations, right?
While using ordinal
Single
representations, we
point
can
crossover it benefit.
single point crossover we can use.
Yeah, that's perfect. So in the usual representations, the path as representation and so such examples, we can't do a single point crossover, because if we do that, the value that we might or the child that we might get might not be a valid representation itself, right? So for example, if we had something like A, B, D, C, and say B, C, D, A, right? And if we choose this point as the single point crossover, let's say the first child we will get is A, B, D, A, which is an invalid representation, because we are not even visiting C and A is occurring twice. So this is not correct. Whereas in ordinal representations, we can easily do a single point crossover. So just finishing the example that we were discussing. So next we have S. S has 3. So this will have 3. We would have considered S. So do you want me to work out the full thing, or will you be able to do the next steps?
We can do.
Not needed, sir.
We can do it, sir.
Okay, so does everyone agree? Okay, we already have an answer. That's great. So 3533625211. Okay, great. Yeah, so I would also encourage it. Try to do it yourself and verify the answer. And if there's any issue, just let me know. Yeah, so this is a step-by-step explanation which I've given in this slide itself. So you can consult it later and have a look and verify whether the answer that you've got is correct or not. Okay, so moving on to the 8th question. Okay, so just another quick question before moving on to the 8th question. So we just discussed that we can use single point crossover with ordinal representations, right? But we cannot do that for path representations. So what are some other crossovers that we could use with path representations? Can you suggest something? Some of the things you might have seen in the lectures.
Cycle crossover.
Okay, yeah, that's one thing. Anything else?
Uh,
Pmax.
Okay, there's
order crossover.
yeah, there's order crossover, there's partially mapped crossover, there are many. So yeah, just a quick detour. So let's go back to our 8th question. So here we'll be taking an example of an order crossover. Okay, so we are given two parents. Okay, these tours, this RUST, this tour, the first tour, the first which is the first parent, and this is the second parent, the P2, which is UXVWQTRPSYZ. And we have to find the two children using the order crossover. And let's say the window is of size 4, starting from the 4th index to the 8th index. Okay, so the one these alphabets marked blue over here are your window. So if we are using an order crossover, which of what is the expected child or children child tour that you will get, a child representation?
R ఇక్కడ ఎక్కడ ఉంది?
Once.
Z, X, X, తర్వాత X, X,
Yeah. So do we have any answer?
P, X, C, D. Next S, E, V ఇక్కడ ఎక్కడ ఉంది? V to V, V ఇక్కడ ఉంది. V ఇక్కడ ఉందిగా V, P, 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 S, S, S,
Okay. Let's do one thing. Let's work it out together, and then
Y to W, W to W to T, T,
we'll
to
see
Q,
whether.
Q ఎక్కడ ఉంది? Q, Q to Y, Y to Y double.
Okay. Let's discuss this step by step. Okay. So for the first child, we'll copy this window as it is. Okay. So we will have T Y Q
I am going
Z.
with this one.
Okay. Okay. And then we'll see from the second parent which of these have already been covered in the first child, and we will remove those. Okay. So we have covered U. No. We have covered X. No. We have covered V. So we will not consider V for the first child. Then W we haven't, Q we have, so we'll remove Q, we'll remove T, not R, not P, we will remove Y, and we will remove Z. So what are the values that we have left over here? We have U, X, W, R, P, and S. So we will just list them in the blanks that were left over here. So if you see towards the left of the window, there were 3 blanks to be filled, and towards the right of the window, there were 3 more blanks to be filled. And we will just list these over here. So here we have U, here we have X, here we have W, then we have R, P, and S. So we got the first child. So was this clear? Okay, so we have one answer. So UXW, TYQZ, VRP, S. Yeah, Z is by mistake. Yeah, that's correct. Itachi Uchiha. Sorry if I'm mispronouncing your name. Yeah. So we got the first child. So was this derivation clear, or is there any doubt about it?
Sir, if we use any other order crossover method, then the answer will be different, right?
So if we use order crossover, then the answer will be this one. But if we use some other crossover, let's say something like a cycle or a partially mapped, then the answer might be different.
Okay.
Yeah. So if this was clear, then can someone quickly tell me what could be the second child? In the second child, we'll...
Can you explain it again? I could not understand.
Okay, let's take the example of the second child and maybe it will be clearer. Okay, for the second child, what we will do is we will copy this window from the second parent directly. Okay, so we will have W, Q, T, R, and P. Okay, and what we have to fill, 3 blanks on the left and 3 blanks on the right. Now we will look at the first parent and see which of these has already been covered in this part. Okay, so R has already been covered, so we'll remove that. U has not, S has not, T has already been covered, so we'll remove T. Then your Y has not been, Q has been covered, C has not been, V has not been, W has been covered, and P has been covered as well. Okay, so what is left? We have U, S, Y, Z, V, and X. So we will simply list it in the order that it is appearing in this parent. Okay, so first blank will have U, second blank will have S, third blank will have Y. On the right hand side, this first blank will have Z, then V, and then X. So was this helpful? Okay, so we have an answer. So let's see. US, Y, W, Q, T, R, P, V, X. Yeah, perfect. So was this clear?
Yeah, now I got it, sir.
Okay, great. So these are the two children that we just derived. So yeah, these were the 8 questions. I'll quickly go over the first question for those who missed it, for those who joined a bit late, and then we'll have a look at the DFID doubts. So this is a repetition of the first question. So this is a influence graph basically shown on the left hand side. Okay, so these are the various let's say species or entities acting in in a closed ecosystem, and an arrow from a particular box to another box implies that the arrow from which the box is emerging, that has a positive influence to the entity towards which the arrow is going. So for example, this bacteria has a positive influence on trees. This is the information that you are getting from these from this influence graph shown over here. This is just an example. Okay, and given this information from this influence graph and this influence graph alone, not necessarily what might be true or not true in the real world, just from this influence graph, which of the options could be true in amongst these options listed on the right hand side. That is what you had to find. And a direct influence is when an entity is connected directly from using an arrow to another entity, and an indirect entity is when it is connected via a path rather than a direct edge. Okay, so here if I just go back to that, yeah, let me just erase these arrows for clarity. Okay, so the options that you can later verify for yourself, but you will see that there are 3 of the options that are correct. First is that grass has an indirect positive influence on lions. How we are deducing that? So here we have grass. Okay, so we are following this path. Grass has a positive influence on mouse, which has a positive influence on snake, which then has a positive influence on hawk. Hawk has a positive influence on fungi, fungi on wildflowers, or we could not go that way. Fungi has a positive influence on bacteria, bacteria on trees, trees on squirrel, squirrel on fox, and fox on lion. So following this path, we can deduce that grass has an indirect positive influence on lion. So this is one of the correct options. The second correct option is bacteria has a indirect positive influence on fungi. How we are getting that? Bacteria to trees, trees to beetle, beetle to robin, robin to hawk, from hawk to fungi, right? And then for the third correct option, we have a direct positive influence from hawk to fungi, because it's directly connected via an arrow. Okay, so this is just an example taken from the lectures to just test your understanding. There's not much of an explanation, I suppose, needed over here. Okay. Varun, I suppose that is a part of the assignment question, so I would encourage you to try to attempt it first. And if there is any doubt, let me know in the discussion forum and maybe we can discuss it in the next week. Okay, so we have some time left, so let me just quickly go over to the DFID question. Okay, and we'll have a very brief overview. Okay, so I won't get into the details of the algorithmic steps, each and every step. I'll just give a brief overview that hopefully helps you understand or gives you a bit of more clarity. So this is a search space given to you. Okay, so remember, this is a search space, not a state space. So this basically means that suppose you had the moved in table over here, so that would mean that from S you can go to A and B, which is basically represented by these two. Okay, and then from A you could go to C and S, which is represented by these two, and then from B you could go to C, D and S, so on and so forth. Okay, this is a search space. Now what the first DFID1 does, it opens only new nodes, that is nodes that have not yet been explored. Okay, so nodes that are already in the open list or that are already in the closed list, those are not explored. Otherwise it just iterates over the depth, starts from depth 0 and iterates over the depths and follows a depth first search in each of the depths. So let's consider depth equal to 0 first. The only node here is S, and S is not a goal node. Okay, so it will move on to the next depth, which is D equals to 1. So here A and B are the two nodes in consideration. Okay, either S or A or B, neither of these are the goal nodes. Okay, and since A appears before B, A is tested first. A is not the goal node, fine, we move to B. B is also not the goal node, we stop it, and then we stop over here for depth equals to 1, and then we try depth equals to 2. Okay, again, so we start with S. S is not the goal node. What are the nodes that it could go to? It could go to A and B. S from S. Okay, and A appears first, so we'll go to A first. Okay, so we are now at A. Now A is not the goal node, and what are the children that A could go to? C and S. Out of these, so C is not yet explored, it's not yet in the open or the closed list, so we add C to the open, and S is in the closed list, so we do not explore S. Okay, so we have a look at C. Now C is not a goal node. Okay, so we go back to B because that was lying in the open list. So the open list was something like C, A, B, V, or C, B actually, because we already explored A. So C is not there, so we'll go to B next. Okay, again B is not the goal, so we'll look at his children. What are his children? C, D and S. So C is already in close now because we explored it here. C is not being explored. D is explored. S is not explored. D again is not a goal node. Okay, so at depth equals to 2 also, this search has failed. Depth first has not found the goal node. So we move to depth equals to 3. Okay, again we proceed in a similar fashion. From S we first go to A. From A we go to C. From C we go to E. From E we first go to F, not the goal node. Okay, so this is depth equals to 3, I guess. So we are not yet going to F. Okay, pardon this. Okay, again, so this is basically we have not found any of these in the E is also not the goal node. A is already been in the closed node, so not discovering this. D is can be included in the open list but is not the goal node, and B is already in the open, so we're not exploring this. Okay, going back to over here B, so again we go to C first. Okay, so we explore in a similar fashion and we find that even at depth equals to 3, we are not encountering the goal node. Okay, so for DFID1, we go to depth equals to 4. And here we go from S to A to C to E to F to C, and then finally at G, we conclude our search. Okay, so it has basically gone from 0, 1, 2, 3, 4 until 4 depths. Whereas if we go for DFID2, it also includes nodes in the open which are still in the closed. Okay, so basically closed list does not have any meaning in DFID2 over here. Okay, so it will first explore 0 depth, S is not goal, then A, then it is not goal node, P is also not goal node, then C, then S. S will be explored over here, remember, because the close doesn't have any meaning over here. Okay, for depth equals to 2, again not working, neither of these are working, this, neither of these are working. At depth equals to 3, however, we find G. Okay, in DFID1, what would have happened when we would have come to this point? Okay, D would already have been explored over here, so we would not even consider this path. Okay, so even though G is at depth equals to 3 over here, we would never have even considered this path, okay, in DFID1. But since in DFID2, we are allowing nodes that are even in the closed list to appear, we are considering D, and here we are getting G, the goal node, in the 3rd depth itself. We don't have to go till the 4th depth. So was that any helpful? Okay, great. Yeah, okay, that's great if that's helpful. So Imtiaz, I guess you have an issue with okay, comma separated list. Okay, yeah, so generally I think Swayam portal has this thing that usually comma separated values are the only way of enlisting it. If you have any like logistic related issue with respect to it, then I would suggest you write to the NPTEL team and hopefully they'll address it in some way. Or if not possible to like reevaluate, they just inform you whether or not it is possible to reevaluate. Okay. Okay, great. So these were the questions for this week. So remind me if I missed any question, or if you want any particular question that you want to be discussed in the next week, that is the 5th week, just let me know either in the discussion forum, or you can tell me now also. So I'll make sure to focus on that for the next week.
Sir, what about group 3 problems in week 4, sir?
What are group 3 problems?
Let me check, sir. They have given about greedy heuristics, sir.
In week 4?
Yeah, it is in week 4 only, sir.
Okay. So today we are at a crunch of time, so I'll suggest that you just try to answer it using the examples shown in the lecture. And if it's not clear, hopefully Bhaskaran sir will also post the solution. So if still not clear, so just let me know and we'll discuss an example in the next session.
Okay, sir.
Okay. Okay, so thank you for attending, and I'll see you next week.
Thank you, sir.
Thank you.
Okay.
Yes, sir. Thank you, sir.